Lesson 23, activity. For this activity, you are doing at least 20 odd numbered problems from 1 to 73 in this collection of review exercises. There isn't any room for me to write the answers that I'm going to come up with in the midst of the actual problems themselves. So make sure you have the problems out in front of you. I've got mine in front of me, but I've just got a blank page that I'm going to work off of here. So starting with number 1, t squared plus 1 to the 100th. So I'm going to be sloppy here. I mean, I should be writing dw dt or maybe w prime, but there's 37 of these things and I'm trying to save some time here. So I'm just not going to write any derivative notation. I'll just write my answers. So I see some stuff to the 100th power. 100 comes down, copy this stuff, subtract 1 from the power, and then multiply by the derivative of the stuff. I'm not going to do any simplifying in any of these. See my earlier comments about me trying to do this quick. We'll try to alternate colors though. Okay, number 3, I see a quotient. So we're going to do the quotient rule. We'll start with the bottom squared, and then we do bottom times the derivative of the top minus the top times the derivative of the bottom. That's just a 1. And I'm happy with that. Number 5, I see another quotient. So the bottom gets squared. Bottom times the derivative of the top. Careful, that's a -1 for the derivative. Minus in the quotient rule. Top times the derivative of the bottom, which is +1. 7. Okay, I see a product rule here. We're doing first times the derivative of the second. That's everything in the parentheses. So 3 ln of x minus 1. The minus 1 becomes a +0, which I won't write. 3 times ln of x. That 3 is a constant multiplier, so it's 3 times. And then the derivative of ln of x is 1 over x. That's the first part of the product rule. Plus the second, copy everything in the parentheses, times the derivative of the first. No need to do a quotient rule. I really hope you don't do a quotient rule. That over 9 is really the same as 1/9, and that 1/9 is just a constant multiplier, so it gets copied, and then the derivative of x cubed is simply 3x squared. The quotient rule will get you there, but you're doing a whole heck of a lot more work than you need to if you do the quotient rule on that one. Okay, number 9. I see e to some stuff, so that is e to the stuff times the derivative of the stuff, and the derivative of sine theta is cosine theta. 11. This is ln of stuff. ln of stuff becomes 1 over the stuff, and then times the derivative of the stuff. The derivative of cosine of stuff is -sine of stuff, times the derivative of the new stuff. The new stuff is w minus 1. It's not required, but technically the derivative of w minus 1 is 1. I'm putting it there at the end. Okay, x to the k plus k to the x. First thing I see is a plus sign. I'm happy to separate these into 2 different problems. K is just a constant. I mean, you can skip anything with one of these constant letters in the problem, but we should be able to do this one. So x to the k is just a number. X to a number is our basic power rule. The k comes down, you copy the x, you subtract 1 from the power. That's it. K to the x is different. Here, the number is in the base and the variable is in the exponent, and this is a to the x. It's that rule. So the rule for a to the x would be a to the x ln of a. In this case, it's k to the x ln of k. So you have to be really careful that you are applying the right rule based on the form of the original problem. 15, sine cubed of theta. There's probably a hint in the answer key that says you want to really rewrite this thing as sine of theta in parentheses all cubed. I'm not going to put that here, but in my mind, I'm visualizing this as parentheses sine of theta, close parentheses, to the 3rd power. And that means I have some stuff to the 3rd power. So that 3rd power comes down. I copy my stuff, I subtract 1 from the power, and I multiply by the derivative of the stuff. Derivative of sine theta is cosine theta. Tan squared of 2 plus 3 alpha. Alpha is our variable here. Okay, again, tan squared, I am visualizing this as tan of 2 plus 3 alpha, that whole thing in parentheses, squared. So that squared is applying to the entire thing. And so I've got now some stuff squared, and so that's the power rule. The 2 comes down, I copy all of the stuff, I subtract 1 from the power, so it should be a first power, but I won't write that. And then times the derivative of the stuff in the big parentheses, which is all of this here. And the derivative of tan of stuff is secant squared of that stuff, times the derivative of the stuff in the inner parentheses, which is now here, and the derivative of 2 plus 3 alpha, where alpha is the variable, is 3. Okay, 19, ln of some stuff. No problem, 1 over the stuff times the derivative of the stuff. Okay, I see a subtraction. I'm happy about that. I'm going to just do 2 separate derivative problems. So the derivative of e to the negative t, that is e to the stuff, which becomes e to the stuff times the derivative of the stuff, and the derivative of negative t is simply negative 1. And then the derivative of that last t in the parentheses is 1. Okay, 21. This is for sure a quotient rule. Big fraction, sine squared of theta. That whole thing is getting squared. If you just write that as sine to the 4th of theta, then you know what to do with those exponents. I'm multiplying those. Okay, so quotient rule. Bottom, original bottom, not the new one, times the derivative of the top. Derivative of theta is just 1, minus the top, times the derivative of the bottom. Okay, sine squared theta, in my mind, I'm picturing parentheses, sine of theta, close the parentheses, squared. That is some stuff squared. 2 comes down, copy the stuff, subtract 1 from the power, so there's an invisible 1 up there, times the derivative of the stuff in the parentheses, and the derivative of sine theta is cosine theta. '23. This again is a quotient rule. Technically, you could avoid the quotient rule if you rewrote this whole fraction as 2 to the w plus e to the w, that whole thing in parentheses to the negative 1. But I'll do the quotient rule here. 2 to the w plus e to the w. That whole thing gets squared. So we go bottom times derivative of the top. And the derivative of the top is 0 minus the top times the derivative of the bottom. Okay, 2 to the w plus e to the w. There's a plus sign, so I'm doing 2 separate derivatives. 2 to the w, that's like a to the x. So 2 to the w stays 2 to the w, but then times ln of 2, the base. E to the w is like e to the x, and its derivative is simply e to the w. Okay, moving over to the next column. I'm going to move over to my next column here. Okay, so we are on 25. Okay, 25. Ooh, a big old square root here. I think that, okay, so you could rewrite this thing as sine of 2z over cosine of 2z all to the 1/2 power. And I think we essentially need to do that, but I'm going to make use of an identity here, which is going to save us from doing the quotient rule inside of the chain rule. Sine over cosine is another trig function. It is tangent. So this problem, I'm going to write something and then I'm going to erase it, but this problem is really the square root of tangent of 2z, which is really tangent of 2z all to the 1/2. So that is the best version of this original that we should take the derivative of. So I see stuff to the half comes down, copy the stuff, subtract 1 from the power, times the derivative of the stuff. Now we're doing the derivative of tan 2z. Tan 2z is tan of stuff. Tan of stuff becomes secant squared of stuff. And then times the derivative of the stuff, where the stuff is now 2z. Derivative of 2z is 2. Okay, next up, 27. Okay, this is a product rule. I see 2 different z things being multiplied together. First, times the derivative of the second. Derivative of sine of stuff is cosine of stuff times the derivative of the stuff. Derivative of pi z is just pi. It's like the derivative of 8z would just be 8. That's the first part of the quotient rule, plus second, so we're copying sine of pi z, times the derivative of the first. 2 to the stuff, that is like a to the x. So 2 to the negative 4z stays 2 to the negative 4z, times ln of 2, that's part of the a to the x rule. And then, I'm going to try to squeeze it in here, times the derivative of negative 4z, which is negative 4. Okay, so I just rewrote that one, so it would fit on one line, 29. Okay, I see e to some stuff. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. So now I'm looking at the derivative of everything that's in those parentheses. And the derivative of e to the theta, oh, because I see a plus sign, so I'm going to do two separate derivatives. So the derivative of e to the theta is just e to the theta. That's easy. Derivative of e to the negative theta, that's a chain rule. That's e to some stuff. So it's e to the same stuff, but then times the derivative of the stuff. The derivative of negative theta is the coefficient negative 1. Okay, I see some more e to the stuff. So that becomes e to the stuff times the derivative of the stuff. Tan of stuff has a derivative of secant squared of the stuff times the derivative of the stuff. The derivative of sine alpha is cosine of alpha, and that one's done. I see some stuff to a numerical power. So this is just the power rule. Don't be frightened by the fact that it's e up there. That's just a number. So the power comes down. You copy all the stuff. You subtract 1 from the power. We'll just write e minus 1. And then times the derivative of everything in those parentheses. Now tangent of 2 is just a number. There's no variable r inside of that expression. So the derivative of tangent of 2 is 0. We're not going to write it. Plus, and then the derivative of tan r is secant squared of r. Looks like a product rule to me. So we copy the first times the derivative of the second. So for the second, I'm imagining, I'm going to write this and I'll erase it in a second, but sine of 3x, that whole thing squared. That's what I'm envisioning for sine squared of 3x. So the derivative of this thing that I've just written down, that's a power rule. So the 2 comes down, you copy the stuff, you subtract 1 from the power, so there's an invisible 1, times the derivative of sine of 3x. That's sine of stuff. Derivative of sine of stuff is cosine of stuff, times the derivative of 3x, which is 3. Okay, that's part of the product rule. Plus, now we do the second. So that's sine squared of 3x times the derivative of the first, the derivative of e to the 2x, that's e to the stuff, times the derivative of 2x, which is just 2. Okay, moving on to 37. This is a product rule. So we go first times the derivative of the second, cosine becomes negative sine, plus the second times the derivative of the first. 2 to the sine of x, that's 2 to the stuff. That's like a to the x. So it's 2 to the stuff times ln of 2, that's part of the a to the x rule, and then times the derivative of the stuff. Derivative of sine x is just cosine x. Okay, e to the theta minus 1. This is e to the stuff, which becomes e to the stuff, times the derivative of the stuff. The derivative of theta minus 1 is just 1. Okay, 41 is another one with lots of constants. You can skip it if you want to. I have like not near enough room there. So let me see if I can maybe put it here, start of it anyway. Okay, but let's see if we can try 41. I see t's in the parentheses and I see a t in a power. So these are two t formulas multiplied together. So that is a product rule. So we go first times the derivative of the second. And you know that t is the variable in here. Number one, it says earlier that a, b, c, and k are all constants. And number two, it says h of t equals. So that t inside the parentheses is the independent variable. So again, product rule. First times derivative of the second. So derivative of e to the negative ct, that's e to the stuff, which becomes e to the stuff times the derivative of the stuff. The derivative of negative ct is just the coefficient negative c. Continuing the product rule, plus second e to the negative ct times the derivative of the first, derivative of at squared plus b. Remember, t is your variable. So the a is a constant multiplier. T squared just becomes 2t. I'll put the t in the 2 in the front. And then plus b, that's just a constant, so that becomes a plus 0, which I won't write. Okay, moving on to 43. 5 to the x plus 2, that's an a to the x, which just becomes a to the x times ln of a. And then the plus 2, that derivative is nothing. Okay, moving on to 45. Okay, here r is the variable, so this one must be a quotient rule. R is on top and bottom. So we divide by the bottom squared. Okay, so we go bottom times derivative of the top. Derivative of a r squared. R is your variable, so the 2 comes down. The a got copied. Copy the r, subtract 1 from the power, so there's an invisible 1. That's the derivative of the top, minus the top times the derivative of the bottom. B plus becomes 0 plus, and the derivative of r cubed is 3r squared. Okay, 47. Arctan of 2 over x, that's arctan of stuff, which is 1 over 1 plus the stuff squared. Stuff is 2 over x, times the derivative of the stuff. The derivative of 2 over x, you could use the quotient rule, but way back when, I encouraged you to memorize a special case for the derivative of a constant over x, and that becomes negative the constant over x squared. If you use the quotient rule, you will eventually get there. It's just a little bit of a shortcut. Okay, and then finally on this page 49, you don't need to use the quotient rule for this one. In fact, I'm tempted not to use the quotient. All right, we'll just use the quotient rule. Okay, so big old fraction here. So the bottom is getting squared. Okay, so we go bottom times derivative of the top. Derivative of 5 is nothing, minus the top times the derivative of the bottom. Okay, the bottom is some stuff squared. So the 2 comes down. You copy the stuff. You subtract 1 from the power. There's an invisible power of 1 times the derivative of what's in those parentheses. Now the variable here is w, which means a squared is just a constant and its derivative is nothing. So the derivative of negative w squared is negative 2w. Okay, when we're ready, we're moving on to the next page for 51. Okay, so starting on the next page with 51. Okay, the variable here is u. That means that the a squared plus b squared on the bottom is a constant. No need for the quotient rule. Think of it as a 1 over a squared plus b squared times, and that constant multiplier just gets copied down. So all we need to do is the derivative of e to the au, where u is the variable, that is e to the stuff, times, and then the derivative of au, where a is the variable, is just the coefficient a. 53. Okay, this one we do need the quotient rule. Copy the bottom and square it. So we go bottom times the derivative of the top, that's just 1, minus the top times the derivative of the bottom. 1 plus becomes nothing plus, and then the derivative of ln of x is 1 over x. 55. Okay, this is sine of some stuff. That becomes cosine of the stuff times the derivative of the stuff in the parentheses there. I'm going to make this a little bit smaller. And while I'm rewriting this, I'll say that we're going to need to think of that square root as being a certain power. So think about that. Cosine of the stuff. And then times the derivative of that radical e to the t plus 1. And we're thinking of that as really being e to the t plus 1 in parentheses, all raised to the 1/2 power. That is stuff to the 1/2. So the 1/2 comes down. Copy the stuff. Subtract 1 from the power, and then multiply by the derivative of what's in the parentheses. E to the t plus 1 just becomes e to the t plus, and then the derivative of 1 is 0. Okay, 57. Oh my goodness, look at how easy that one is. Just a polynomial, so 18x squared plus 8x minus 2. 59. Okay, this one, you could do the quotient rule, and that's totally fine. I'm going to encourage you to do this one in an easier way. I'm going to write it here in its original form. But then I'm going to take this and split it into 3 fractions. I've got just a single term downstairs. And 3 terms on the top. And so I can split this up into 3 fractions, each of which has this denominator of z squared. Make sure you buy that that's allowed. After all, if I gave you this thing I just wrote down and I said make 1 fraction, you would just smush it together with a single z squared denominator. And then we can simplify each of these fractions now. Subtract those powers. Z to the 5th plus 5z to the 4 minus z. And my goodness, that's an easy one to take a derivative of. So there's no calculus in what we just did, but now the calculus is taking the derivative of the final thing we wrote. 5z to the 4 plus 20z to the 3 minus 1. Of course, if you use the quotient rule, you'll get an equivalent answer, but it would be a whole lot more work, and you'd have to do a lot of algebra to get your answer to be in this nicest form right here. 61. X to the 3rd plus 3 to the x, so plus sign separating our 2 independent derivatives. 3x squared, easy there. 3 to the x is not the power rule. This is the a to the x rule. 3 to the x times ln of a, ln of 3 in this case. 63, okay. So I am going to rewrite, but I'm going to erase it, so make sure you get it here. So this is cosine of 5 theta. That square root translates to 1/2, plus, and then sine of 6 theta. And that whole thing is squared. That's what the sine squared means. So this is the version we're going to take the derivative of. So 2 separate things with plus sign in the middle. First one is some stuff to the 1/2. 1/2 comes down. Copy the stuff. Copy the stuff. Subtract 1 from the power times the derivative of the stuff. So the derivative of cosine of stuff is negative sine of stuff times the derivative of the new stuff. The derivative of 5 theta is 5. Plus, that's the big plus sign in between. And now the derivative of sine of 6 theta all squared, that's another stuff to a power. So the 2 comes down. I'm going to start erasing here. This is in my way. So the 2 comes down. You copy the stuff. You subtract 1 from the power, so there's an invisible 1 as a power, times the derivative of sine of 6 theta, that's sine of stuff, which becomes cosine of stuff, and then times the derivative of 6 theta, 6. $65. So you could do the product rule here. You will get the right answer, but you're missing the boat if you just blindly do the product rule, because we can distribute here, right? So if you do first, outers, inners, last. So the first, when I multiply, gives me s to the 4th. Add those powers. The outers gives me plus s squared radical s. The inners gives me minus s squared radical s. Hey. And the last give me just s, right? Because those radicals cancel. And so also canceling is this s squared radical s from both. So really, the original problem before we do any calculus is just s to the fourth minus s, and that derivative is a piece of cake, 4s cubed minus 1. Product rule will get you there, but it'll be a whole heck of a lot more work, and you'd have to do a bunch of simplifying to get your answer into this nice form. 67. Okay, this one I see t's times t's. Can't avoid the product rule here. First times the derivative of the second. So there's a plus sign in between, so there's going to be a plus sign in between here. So derivative of sine of stuff is cosine of stuff times the derivative of the stuff. Derivative of at, where the variable is t, is just the constant a. Plus, now we've got cosine of bt, so that's cosine of stuff, and derivative of cosine of stuff is negative sine of stuff. I'm going to go ahead and change that to negative sine of bt. And then times the derivative of bt, b is the variable, it's again just the coefficient b. But this was only the first part of the product rule. Now we do plus the second, we copy everything in the original parentheses. Multiply by the derivative of the first, e to the kt is e to the stuff, so that becomes e to the stuff times the derivative of the stuff, and the derivative of kt is the coefficient k. Okay, not too many more left here. Moving on to the last column. Okay, here we go with 69. All right, sine of 2t. So this is some stuff to a power. So let's do our power rule with the chain rule. So the 4 comes down, copy all of the stuff. Subtract 1 from the power. And now times the derivative of everything in the big parentheses. Okay, I don't know if we have room here. Let's try it. Sine of 2t, that's sine of stuff. So that becomes cosine of the stuff times the derivative of 2t, which is 2, minus. Derivative of cosine of stuff is negative sine of stuff. So we're going to just change this to a plus. Plus. We're having trouble just changing it to a plus. That's good enough. Okay, so cosine becomes negative sine of 3t, and then times the derivative of 3t, which is 3. Okay, good enough. Are we done? Yeah, I think that one's good. Okay, moving on to 71. So this one, I guess I would probably do the product rule here. In some sense, I'm tempted to do the same technique that we just did in 65, where we do some distributing. In 65, it was FOIL, but really it's just the distributive property. So you could distribute in 71. You'll get a rather large polynomial. Not a whole heck of a lot of those terms will combine, but you can do it. Because I can see that not much nice is going to happen, I'm just going to go ahead and do the product rule in its current form. First, times the derivative of the second. 6 goes away. Derivative of negative 4x is negative 4 plus 7x to the 6th. Plus, continuing the product rule, second, times the derivative of the first. That 4 goes away. Minus 2x plus 6x squared. And that one's done. '73, last one. Okay, I see lots of plus signs and minus signs, no problem. We're just going to do these ones separately. So the first one is square root of 5z, which is 5z in parentheses to the half. Write that if you need to, but I'm just going to dive in with the derivative. 1/2 comes down, copy the 5z to the negative 1/2 power, and then times the derivative of what's in those parentheses. Derivative of 5z is 5. Plus, derivative of 5 square root of z, that 5 is a constant multiplier, which is just hanging out. And in my mind, square root of z is z to the 1/2. And so that becomes a 1/2 z to the negative 1/2. Plus, okay, 5 over square root of z, that becomes 5 over z to the 1/2. but I really don't want to do the product rule there, so let's write that as 5z to the negative 1/2, all upstairs. And so the 5 gets copied, and then z to the negative 1/2, the negative 1/2 comes down, copy the z, and then subtract 1 carefully. It was negative 1/2, so now it's negative 3/2 minus. Okay, square root of 5 over z. So I'm thinking of that as 5 over z in parentheses, all to the 1/2. 1/2 comes down, copy the 5 over z to the negative 1/2, and then times what's the derivative of what's in this parentheses. 5 over z, you could use the quotient rule, but again, a constant over x, we have the special case, negative the constant over x squared. In this case, it's negative 5 over z squared. And then finally, plus square root of 5, I won't write the plus 0 here. The derivative of square root of 5 is nothing. Okay, so lots of practice with these derivatives. It's important to get good with these rules. As I said before, you can just stop with the unsimplified versions of the answers. I do have versions of those in the packet. But if you'd like, you can try your hand at doing some algebra simplifying. That might take some work for some of these.